Good afternoon. My name is Ian Coates, and welcome to the Week 9 Statistics 1001 PowerPoint A. This is the first one. Hi, guys. I hope you're all doing well. Again, thank you for the accommodation here. I've got a pretty good doctor's appointment there. And hopefully there, my message will get to a greater audience there. I tell you, those statistics classes at 8 o'clock in the morning, they're not nice, are they? Well, how today's class is going to go, as you can see in the folder there, there's three videos or so. And how we're going to work it is we'll do one video there for the 9A PowerPoint, and then I'll stop it, and then we'll go for another PowerPoint there for the 9B. And then I'll do a little bit of a third PowerPoint there, and we'll go over the assignment that's currently out there to give you all there a fighting chance, because I know it's probably a good one, okay? But it's all right. We've done this there in the past, and the results have been very good. So keep at it and work on it there. Bounce ideas off of each other, and it's a good way to get ahead in this course for sure. And just a last note there. This is where the course starts to get a little thick. So don't lose confidence. Don't lose, just stay focused on this stuff and you'll do great. Okay, so with no further ado, let's get on with PowerPoint 9A, Estimation and Confidence Interval. Okay. So confidence intervals here, we're talking very often psychologists, and even right now we're in the middle of, we're going to be looking at an election soon, okay? And what we're talking about here is estimating the population of smokers given a sample of smokers, right? The whole idea there is that the only thing you have is a small sample of smokers, and you're trying to estimate the entire smoking population. Who will be the next prime minister based on a small sample of people who were polled before the election, predicting the election. What's the average weight of students at a particular college based on a sample of students, right? So two types of estimates there are often distinguished. We got point estimates, which I'll talk about briefly, but we'll look at interval estimates there. Okay, that's the big one. So when we're talking about confidence intervals, they're sometimes used instead of or even alongside an ordinary hypothesis testing methodology. Confidence intervals do not include the mean of the null hypothesis distribution, and if they don't, then they tend to be statistically significant. And we'll show you what that means there later on. Rare for researchers to know the characteristics of the population distribution, right? Like, because all you have is a sample of smokers. How do you know what the real population of smokers is, right? So it's kind of a chicken and the egg kind of a thing. Point estimates, an approximation of a single value. We do use point estimates. You guys have used them there 100 times so far this course. It's usually the mean, all right? Like the axis of where the distribution falls on either side. Example there, estimating the mean weight of Georgian college student population. That mean weight would be a single number, a single point, the mean. All right, so we've done point estimate. Let's have a look here. Now, trying to estimate, and the whole conundrum here is that you have a sample of smokers. Okay, now that comparison distribution, like it's not the population, the fatter distribution, right? These are the thin distributions. So this is the distribution of the means. So the mean of this sample, from what population did it come from? Right? Did it come from this one, this one, this one? And you remember the whole idea of standard deviation. Called the standard error. And if I'm going to take a small number of people and project that onto millions, well, there's going to be a possibility of error. And you calculate that and you add that into your answer. So the estimate of a specific value of a population parameter. Here we're talking about the mean, right? Point estimate. The best estimate of the mean of a population is the mean of the sample taken from that population. So this sample of smokers here, it came from the population of smokers, but we don't have that information yet. So the standard deviation of the distribution of means, called the standard error, is a measure of the accuracy of that point. So that's the whole ball game here, is you have your sample. Now, where did it come from? Where is the mean of the original sample? And what kind of error do we have associated with estimating it? So interval estimate there is an approximation of a specific range, an interval there within a distribution. The range has an upper bound and a lower bound. See? If you estimate there that this sample, this mean came from a population that the mean is from here to here, you're going to have a certain percentage of error associated with it. Okay? But there's going to be a lower level and an upper level. So somewhere in here, this mean came from in here somewhere. All right? Confidence interval usually expresses a percentage, an interval estimate that is based on considering a specified level of risk. Okay, 95% confidence interval, 99% confidence interval, 90%, we got it. An example there, for Denison students at a particular college there, the 95% confidence interval for weight might extend from 125 to 165 pounds. Okay, lower and upper level. That is, we are 95% confident that the mean weight for the Denison population is between this range. Okay, so you'll have a look here, and if you can somehow express these three, okay, you have a look at the middle one here. And this mean came from here. But where did it come from within here? And you look at this population, the middle hump here, okay? And you've got data that falls here, 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 and all the way over here, and on the other side as well. So where did this particular sample come from? Okay, that's what we're going to be looking at there later on. The interval estimate with a given likelihood, okay, of including the population mean. That's kind of what we're talking about here with these confidence intervals, where the interval estimate, you're estimating, right? You have your sample and you're estimating that onto a population that you didn't know existed before, right? So you interval estimate there with a given likelihood of including the population mean. Typical confidence intervals there, we know this there, 95%, 99. The larger the interval, the greater one's confidence that the interval contains the true mean. Now, let's just go back here. Let's just say there that we estimate there that the mean fell within here and here. So that's pretty tight. Okay, that's a pretty tight area. So I'd probably have lower confidence, maybe 68%. Like there's the first standard deviation, and we're just talking about the middle. Here, I'll zoom in a bit. Okay, so we're just looking at the middle hump here. We're trying to estimate where this came from. And if we say one standard deviation, so 68%, 34 and 34, that's a pretty tight area. So my confidence is going to be low. Okay? If we start expanding, 2 standard deviations, okay, my confidence is going to get better. 95% of, I have 95% confidence that this sample came between the second and second standard deviation. But you see what happened there? With greater confidence, we were at 68%, but it was tight. We expanded our range, so now, we've got a greater variability, but with that greater variability, we also have a greater confidence. And we could even expand that to 99%. So you know what I mean? We're all the way out to third standard deviation almost. So my range has gotten, almost too wide. Okay, so my mean came, the mean of this sample came, I have a 99% confidence interval that this sample came from here to here. So it's all just a matter of, type 1 error, type 2 error. Do I zoom in? How far do I zoom in? Because if I zoom in too far, I'm going to miss information. If I zoom out, okay, all right, that's fine, but I'm going to lose confidence. So that's the nature of statistics, right? So going back into this slide here, the interval estimate with a given likelihood of including the population mean. And you guys know these numbers there, within 1 standard deviation, within 2, within 3, 68, 95, and 99. The larger the interval, the greater one's confidence that the interval contains the true mean. The smaller the interval, the less confidence. And whenever I'm teaching, somebody calls. It's just lovely. All right, just going to put that on mute. Excellent. Moving on. So, confidence intervals here, the upper and lower boundaries of the confidence interval need to be specified in the same unit of measure used for the mean. Computing confidence interval requires using z-scores. Okay, so when our data graph contains an error bar equal to plus or minus 1 standard deviation, we are essentially saying we're 68% confident that the population mean falls within this boundary. And that's what we were saying there before. It's a pretty, you're trying to estimate your sample onto a population. Yeah, that's pretty exact, which means our confidence will be lower. Okay, and that's where we got these numbers from there. You have a look here. If we want to go 95%, so now I'm going to estimate my sample is going to fall, it came from within here. Okay, my variability has gone way up, but so is my confidence. Okay, and you'll see those numbers there, 95%. Okay, and then if you want to go 99%, now we're at z-score plus or minus 2.58. There's your standard error. Okay, my variability has gone way up. My confidence has gone up. All right. Let's have a look here, shall we? So, you have a look here. Steps for figuring a 95 and 99% confidence interval. You've kind of already done this there. And I'll just put that right there. Good. So you'll see we're going to estimate the population, and the best estimate that you have available to you is your puny little sample. Funny enough, eh? So you figure the standard deviation of the distribution of means. Okay, you find the z-score that goes with the confidence limit there you want. You guys have seen these numbers there before. If you're looking for 95% z-scores, there are those. For 99%, you're looking for these ones here. Convert your z-score there to a raw score. You've seen these. If you go back to the week 3 or week 4, I think it was week 3 there, we introduced this. The whole idea there of you can calculate your z-score, but then you can also flip it, and you can calculate from the same formula your actual raw score from the z, standard deviation, and the mean. So just an example here, and I'm just kind of throwing this at you, and we'll in the next PowerPoint 9b we'll follow up with this there some more. But if you wanted to find the z-score that goes with the confidence interval you want, 68%, 95%, or 99%. In this case here, I give an example there for 99% confidence interval. Okay, z-score are plus and minus 2.58. So according to the formula, there you go. Z times standard deviation plus M, Z. Okay, now remember, you're going to have a lower limit and an upper limit, right? So be careful about your Z scores. Okay, lower limit there, it might fall within the, a negative range. So that one there may be negative. I'm not saying always, but it may be negative. Something there to watch for, So there's your negative z-score times your standard deviation that we calculated, but we'll show you guys all this there. I'm just showing you guys a sample calculation here, plus a mean of 65. So you'll see there that 64.17 in this case here would be your lower limit, okay? That would be your raw score. And then you calculate your upper limit. There's your upper Z times same standard deviations times same mean. And we get an upper limit of 65.83. So in this particular case here, we would have a 99% confidence that our sample came from this population that has a mean from here to here. And sorry, my numbers were 64.17 and 65.83. Now again, these numbers won't make any sense to you because they're from the 9B PowerPoint, but just showing you there that we now have our confidence intervals. Okay, at a 99% confidence, we're confident there that our sample came from this population that has a mean, okay, a lower limit there, 64.17, to an upper limit of 65.83. Last slide here for 9A. It's exactly the same thing as what we just looked at right here, just on its own slide here. So remember there from week 3. Okay, and just showing you this right here, what's going on. Let's stop this PowerPoint, let's stop this video here for right now, okay, and then please move on over to 9B. Thank you very much.